So we looked up a couple of rules for dealing with exponents in the previous video on multiplying and dividing monomials. One of those was the multiplicative rule of exponents, which just says you add the exponents. So a plus b, let me redo that, a plus b, and that's because you have a of these and b of these, so this is ax's and bx's, so that's a plus bx's altogether. X to the a over x to the b is the division rule of exponents, which says you subtract, and that's because when you cancel out, the remainder will be what's left, or their difference. We looked at the negative exponent rule, which says if you have a negative exponent, it moves either up or down depending on where it started, and then becomes positive. So if it was in the denominator, like this, it would actually move to the top, become positive. And I believe we also looked at the zero rule, which is any number to the 0 power is 1, except when x is equal to 0. And that's because that's the same thing as saying 0 to the second over 0 to the second, which would be equal to 0 to the 0, which is undefined. And the reason for that is any division by 0 is undefined, and 0 squared divided by 0, no matter what the power is undefined. Alright, so let's look at a few other exponent rules that we haven't looked at yet. So let's get rid of all this. Okay, so there's the power rule, which we did not mention yet. That is x to the a to the b power is equal to x to the a times b. So the multiplication rule was a plus b, but the power rule is a times b. And more important to mention before that is something everyone should know, which is the no exponent rule, which isn't really a rule, it's just something you're supposed to know. If you have a number without an exponent, its exponent is 1, even if it's a whole number. 6 is really 6 to the first, and that's going to play a role here. So let's look at an example. Let's say we had 3x to the fourth, y to the second, all of that being raised to the second power. By this rule, we'll get 3 to the first it was times 2, and x to the fourth times 2, and y to the second times 2, which is 3 to the second, x to the eighth, y to the fourth. And since 3 to the second can be simplified, that's 9, x to the eighth, y to the fourth. Alright? Another way to look at this is the same thing as saying this. It's squared, so it's being multiplied by itself. So 3 times 3 is 9. X to the fourth times x to the fourth is x to the eighth. And y to the second times y to the second is y to the fourth. Either way works, but if this was a larger number, let's say 10, you wouldn't want to rewrite this 10 times. So knowing the rule is important. Alright? The biggest mistake that people have when they do this is they forget that if there is no power on the 3, it doesn't have a power. It does. Its power is 1. Alright, so let's take a look at the next exponent rule that we haven't looked at yet. It is probably the most disturbing and daunting one of them all. We won't be using it for a while, but we will be using it at some point. So let's erase what we have here. Alright, and we're going to look at fractional exponents. Now this we're probably not going to use for a while, so you can remember that this is here, not fractionalize. And why do I call them fractional? We've already discussed that fractions are referred to as rational numbers. So these are rational exponent rules. There's really only one rule, and that is any number to the a over b power is equal to the bth root of that value to the 8th power. It's also equal to the bth power a times. I'll show you why this works. Let's say we had 2 to the 1/2 power times 2 to the 1/2 power. That's equal to 2 to the 1st power by the additive rule, or the multiplication rule. 1/2 plus 1/2 is 1. So these two things multiply together and equal 2. Alright? So this is 2 to the 1/2 squared equals 2. So by taking the square root of both sides, we get 2 to the 1/2 is equal to the square root of 2. We don't list the 2 here for a square root. But we can do the same thing for the cubed root. Let's say we had 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3. That would be equal to 2. So this is 2 to the 1/3 cubed equals 2. So by taking the cubed root of this side and the cubed root of that side, we get 2 to the 1/3 is equal to the cubic root of 2. And we can do that for any denominator, any unit fraction we have here. Alright? So then the question becomes, where does this come from? This numerator part here. Let's erase these for now. So we have 2 to the 2/3. That's going to be equal to the cubic root of 2 squared, or the cubic root of 2 squared. Both ways work. The question is why. This is the same thing as saying 2 to the 1/3 times 2 to the 1/3, which is equal to cubic root of 2 times the cubic root of 2, which is the cubic root of 2 squared. So that's where this one comes from. Another way to look at it, and why it would become this one, is this is 2 to the 1/3 squared by the power rule. Actually, I think it would be better to write it the other way for this example. 2 squared to the 1/3 power, also by the power rule. So this is now the cubic root of 2 squared, which is here. Alright? So hopefully this made some sense. If not, ask me in class for more assistance.